Good afternoon, ladies and gentlemen. Welcome to this Global Network Forum. My name is Maria Cristina Falvella. I work for Italian Space Agency, and I'm very pleased to have you here, and I thank you all the speakers to be here. As discussed in these days in Adelaide, you see that both robotic and human exploration are pillars of many space strategy. We are convinced that after 2024, possible new scenario will be on the table. And of course, we expect to exploit the decades of investment and the lesson learned, but we are also conscious of the fact that the boundary situation is quickly changing and there are new actors, new capabilities. Italian Space Agency, as one of the major commitment country in exploration, is very interested in see which are the parameters which drive this evolution in order to exploit all the possible capabilities and to benefit in the short term of the results at the global level. For this, as you say, we, on behalf of Professor Battiston, which is the president of ODASI, we invited all these distinguished guests. And they are all well known, but let me introduce them, highlighting how crucial they are for the future roadmap. They will present their vision. Also to show you that there are many possible things, but the decision is not trivial and the scenario is really complex. Welcome first to Frau Ehrenfreud, the chair of the executive board of DLR. As you probably know, Germany is the first contributor of exploration program in Europe. So it's very committed on the exploration and the future program. Welcome to Mr. Bill Gestermeyer, Associated Administrator for Exploration and Operation of NASA, and well known as the International Space Station. Welcome to Mr. Krikalev, the Director of Exploration for Roscosmos. Roscosmos is a true pioneer, and Russia is a true pioneer in exploration. Yesterday, we remember the Sputnik mission, but you for sure remember also the successful Mir station and the current involvement both of NASA and Roscosmos in the International Space Station. Welcome to Mr. Gomi from JAXA. JAXA is a member of Space Station 2 and contribute with the laboratory Kibo to the station. And Mr. Gomi has an important role now because he is the director of the preparatory office for the second International Space Exploration Forum, which will be held in Tokyo next year, and which will convene all ministers in a forum for exploration. Welcome, Mr. Werner, the director of the European Space Agency, an important partner of the International Space Station, and welcome to Mr. Sylvain Laporte, the president of the Canadian Space Agency. Canada is also a member of International Space Station, contributed with the robotic arm. It is the only non-European country who sits in the ESA Council as cooperating states, so very committed in space at global level. Very welcome to Mr. Yu Long from the Chinese Space Agency, the Chinese Space Administration, the Secretary General of the CNSAI. China is not a member of International Space Station, but thanks to their capabilities and their commitment, they develop and operate in orbit an autonomous space station. And welcome to Mrs. Simonetta Di Pippo, which represents the United Nations as the director of the United Nations Office for Outer Space Affairs in Europe. She is a former director of exploration in ESA, and she will tell us after more about their commitment also for exploration. Very welcome to Monsieur Jean-Yves Legal. Monsieur Jean-Yves Legal, the president of GNF, chair of the ESA Council, and even president of GNF, represent France. France has been for many years an outstanding partner in all space activities. And last but not least, Mr. Roberto Battiston, the president of Italian Space Agency. As I told you, Italy is also very committed in exploration, is the leader of ExoMars 2016 and 2020 mission, and contributed in a significant way to the development of, as you see from the video, of the ISS modules. So now we go on, and what I propose our distinguished guest is a challenge to give you a picture, a quick picture of the vision for the next 30 years in 5 minutes. They can do it because they have a very clear pictures. And at the end, you will have a quite complete picture of what is running around the world at the highest level. And then we can have some questions and start the discussion. The only thing that I ask our guests is to try to respect their slot in order to give their colleague time to intervene and even to have further questions after. Let me start from the lady near me, Mrs. Ehrenfreud. Please. Mrs. Ehrenfreud, the chair of the executive board of DLR, and your slide should be should appear.
They should appear. Yeah.
Yes.
Anyway, I can probably start. Before
No,
that.
this is Mrs. Ehrenfreud.
Jan, I can also speak for Isa. Anyway, I can start. I think we have a federal strategy for space, and one of the major goals is scientific exploration. And from DLR's point of view, we think that a stepwise approach for exploration, also for the future, is foreseen. We are working a lot on the International Space Station. Actually, we contribute about 38% to the European segment of the ISS. And that's why we have a very large community and are interested in exploiting also further the low Earth orbit, also to explore the Earth's moon, and to go deeper into space and journey to Mars or so. I think we need some kind of lessons learned and also matured capabilities, which we in Europe hopefully also learn from the ExoMars mission. So we are very fortunate that next year Commander Alexander Gerst will be on the space station, the first German commander for 3 months between August and November 2018. And he will actually work on, hopefully, 35 experiments. And its focus is also really aerospace, but also experiments which are important for tech transfer and for challenges like Industry 4.0. So we also are interested very much on the robotic exploration of the lunar surface. We do a lot of technology and robotic, which can also be used in autonomous navigation planning. I have just introduced it in the previous panel. I will not go into detail, but within the European E3P program, we contribute to the future missions, which we do together with Russia, with Lunar Globe and Lunar Source. For instance, landing technologies. And for the future Mars exploration, we are very happy to partner for the InSight mission with NASA next May with our heat flow probe. And we also contribute together with the US and France, one of the most capable instruments for life detection on the ExoMars mission 2020. So we also, with our Japanese colleagues, that's also exploration. Asteroid is one of important target, and we will drop our mascot lander with German and French instrumentation on the surface of asteroid Ryugu on 1993 GU3, and hope that we can explore and learn how to go further with asteroids. And I want actually to end with this really nice chart. I was lucky enough to be in the National Academy in the US in the committee, and we did this pathway for exploration. And it was a question of rationales, and it was a question of what is possible, what is financially possible, how do we cooperate globally. And I think these points which are mentioned here, they are very, very critical in order to go forward nationally, European, and on global level. We have to satisfy many rationales, be they economic, international, science, education, but it is also that we have to involve many more partners, and that we have also to have commercial collaborations for the future in order to leverage financial resources and also capabilities of other nations. And with this, I just want to end. Short speech.
Thank you.
I hope I'm in time. Yeah.
Thank you for your presentation. I leave a question for the end of the, and I please Mrs. Simonetta Di Pippo to go and.
Okay, here I am. Yeah, good. Welcome, and what I would like to do first, I mean, I have to apologize because 5 minutes to 5, I have to leave this discussion here, probably in the discussion part, because we have a GNF on the 50th anniversary of the Outer Space Treaty that I'm running, so I'm very sorry, but I wanted to, let's say, inform you that I have to leave in around 5. So, you probably, if you have been following various other plenaries in GNFS, you already, in a way, are acquainted now and familiar with this, but let me just summarize the fact that we, the Office for Outer Space Affairs at the United Nations, have a unique role in the UN system, and I would say on a global scale. Our main goal is really to promote international cooperation and bring the benefits of space activities to humankind, which, as I'm used to say, is quite a broad mandate, and clearly exploration and innovation is just one of them. In order to do that, we really do a lot of capacity building activities and training, and we get in touch with developing countries and emerging countries mainly, but not only, also we do a lot with developed countries, always on a global scale and always with a global approach. And if we talk about the topic today, where we will be in 2025 and 2030 and beyond, we recently started what we call access to space, which is not only access to space with hardware, but it's also access to space in terms of access to space-based data and infrastructures developed by others. So just to have a real open and inclusive access to space from for everyone, everywhere. We started this activity under the umbrella of an initiative which is called Human Space Technology Initiative, started in 2010, so several years ago. It was mainly devoted to capacity building workshops and training activities, and then we evolved towards what we call holistic access to space program, where we try to develop step by step a comprehensive program where we can allow through several agreements and several kind of agreements with private sector, with space agencies, with governments, with NGOs. We try to really bring all the potential players in the game and try to have a comprehensive and well-structured, let's say, framework in order to allow everyone to potentially join access to space program. And as you can see, apart the various activities, the KiboQ program with JAXA, the CMSA agreement, so the China Manned Space Agency, where we are having probably an announcement of opportunity by the end of the year. KiboCube, we just announced the third round, the third announcement of opportunity. Dream Chaser, yesterday we had a press conference where we released our call for interest, and now we are looking at exploration, Moon, Mars, and beyond. What is important in this slide is not only the various initiatives, but also is the involvement of the various players and stakeholders. And this is really quite new in the system, because there is no organization at all in the world potentially dealing with all the stakeholders. And what is really important is that we are preparing for Unispace Plus 50 together with member states. There are 7 thematic priorities we have to work on. The number 1 is on global partnership in space exploration and innovation, and member states asked us to always link innovation with exploration, which is a clear mandate for us as the Office for Outer Space Affairs. And there is an action team in place made by a certain number of member states and also some observers at the Committee on the Peaceful Uses of Outer Space. And interesting enough, this action team is co-chaired by 3 countries: United States of America, China, and Jordan. So it's already a huge coordination effort just only to when we set up the co-chairs team. There are a lot of activities that this action team has to work on, and by end of November, the final report should be ready, where we expect that the action team will present an idea for a global coordination mechanism for the future activities. And this will enter into a new vision for the UN in space, which is called Space 2030, and clearly we will include the low Earth orbit in this plan, but we are looking really the long-term future exploration of the solar system. Space 2030 is not addressing only exploration and innovation, a lot of other thematic priorities and initiatives, but will be really shaping the future of space activities under the umbrella of the United Nations and our 193 member states. And thank you very much for your attention.
Thank you, Simona. Thank you for having given the flavor that exploration is not only for the big country who commits for space and so on. And good luck for your program. May I give the floor to Mr. Gessermayer? We want to offer you the vision of NASA.
Okay, thank you. I would say this is maybe not a NASA vision, but this is really the vision we're trying to put together for all of us. There's nothing that on this chart that we described that we can do alone or we're going to do alone. We're going to do this internationally. We're going to do this with the commercial sector. We're going to do it with large space nations, with small space nations. The challenges and demands that are required to move human presence in the solar system requires all of us. So this is a framework, a discussion piece that I think that we'd like to put out, and then see how other countries, how other companies, how other individuals, how students can all figure out ways to contribute to this idea. So where we are today, we're on board the space station. It's an amazing time on space station. We're starting to get a good commercial response. We're starting to get very interesting results in space for the first time. We've been able to sequence the full human, or the full genome of many bacteria on board station for the first time. The research is pretty phenomenal. We're going to be able to look at some fiber optic cable manufacturing 100 feet or so within the next month or so on board station. So this is really a transformative time. So we need to use the station as much as we can for commercial activities, to see if there's interest from other non-space agencies in using the unique properties of space. We also need to use station to help us prepare for the next step. Can the human body tolerate thousands days in the microgravity environment, in the radiation environment? What do we need to do to keep the human healthy? And also, what systems do we need to operate? The life support systems we have on station, they're not acceptable for those longer durations. They break too regularly, they require too much maintenance, and the closed loop life support systems are not closed enough. We recycle about 86% of the water today on station. We want to drive that to 95 or 96% of water closed loop. So there's many challenges, but station is a perfect platform to do that. That's what we want to do on station. We also want to use this phase to set some standards for deep space, some things that we all agree are the right things to do. We have the International Docking Standard in place. We'd like to set the pressure limit for modules, so when we attach two modules together, we don't have to have an airlock between the two. We'd like to set some things in terms of oxygen, nitrogen concentrations in the atmosphere, to put down some interoperability standards, so anyone that builds hardware can interact and put things together. And then lastly, we'd like to do during this early phase is understand if there are resources on the moon that can be used for future architectures. We know potentially there's hydrogen and oxygen on the moon, possibly in the form of water, more than likely in the form of water, but how is that moisture or that water held in the regolith? How difficult will it be to get it out? And could it be used for a propellant source for missions beyond the Earth-Moon system? So we want to do fairly quickly some test sampling of the lunar or the polar regions on the moon to see if we can understand how those volatiles are held. Then in the 2020s, that's where we call the proving ground, or where we're gaining some more experience. We talk about a concept called Deep Space Gateway. We believe we can have that in place by that time frame, probably the mid-2020s, and that's with the vehicles that are in development today. We have the Orion vehicle under development for its flight in 2019, on top of the SLS rocket, which is also scheduled to fly with Orion in 2019. Then we fly Crew for the first time in 2022. That begins the construction of the gateway, and then by 23 and 24, we can have in place the gateway, which is a place for where we can demonstrate the next phases of things we want to do going forward. We want to keep that architecture open. The gateway is crew tended. It's used by crews from anywhere from 20 to 46 days to do scientific investigations on the moon. It can be moved to different orbits around the moon. It can go from a halo orbit around the L2 position. It can be in a near rectilinear orbit, which is just a highly elliptical orbit around the moon, which is good for transit beyond the Earth-Moon system and also coming back from the Earth-Moon system. So it's a multi-purpose station, a multi-purpose gateway, and we expect that, again, it would be able to be used internationally by a variety of users during this time frame, and also potentially commercial. And we have early activities started in that area. We're already beginning acquisition of the power propulsion element. We're starting to put concepts together, both with the private sector and international community, on the habitation segments of that vehicle, and we're moving in that direction fairly quickly. Then by the end of the late 20s, 2029 or so, we'd like to have the deep space transport in place, do a one-year verification flight of that vehicle, and then after that, roughly in 2033 or so, we're ready to go to the orbit around Mars. So again, I think the important things to think about here are, this is moving human presence in the solar system. This requires all of us to work together. We're trying to create a framework that is open, that is robust, that builds off of pieces of hardware that we built before. It doesn't require a huge new budget to go do this. Those are the basic underpinnings of what we're trying to do as we move forward. So again, this is where we see the future is bright. I think we see a chance to really take what we've done in space with the space station, what we can do internationally with our partners, with what they would like to contribute. We can weave that together into a scenario where we actually achieve this vision in a sustainable fashion as we move forward. So again, thank you.
Thank you, Mr. Krikalev. You are very welcome to present the Russian vision.
Actually, when we say we need to start do something for future exploration, for deep space exploration, actually I think we already started it, and we started it a long time ago, because we started to send probes to other planets actually in the beginning of space exploration. We are going to continue this line because we have several probes, several lunar probes that are going to be sent robotically to the moon. And actually, the idea of sending this module is to get more data for future human exploration. We said that we are going to do future exploration in international cooperation, and we started to do this also a long time ago. We did our first Apollo Soyuz mission when we start to do human cooperation in space. We had many missions on Salyut station and then on Mir station, getting ready for future international exploration. And now we work for many years already on International Space Station doing things together. And what Bill just said, that this is essential part, because we need to learn how to do this. And it's not easy all the time. We have problems, and we getting ready to overcome all these problems, because it's not very obvious how to do this when you see some problems. For future deep exploration, of course, what was said before, that we need to build infrastructure, and the first part is actually transportation system. The things we are doing now, you probably know that Russia is building new launch facility, Vostochny, that is going to be used in future for super heavy launch vehicle. We had a very long discussion which way to go, and probably we realized that the team of scientists, team of engineers that was working for several months, actually several years already, trying to determine what is the best way, what is the most efficient next step. And what Bill just said, that this international group already defined that probably next step would be in high elliptical moon orbit. Russia is building also a crew transportation vehicle that is going to be capable to send people not only on low Earth orbit, but also beyond low Earth orbit, and being able to fly toward moon orbit and toward moon, to send people to moon. So many things are done in parallel, and again, we have a pretty good history of how we did it before and how we are going to do this in future. But I think another things I mentioned on previous session, that in order to have most efficient solution for many problems, we need very good team. And team not only staying in the future villages on the moon, on Mars, but also team of people who are working here on the ground. And I think that is very important, that we are being here trying to convey our ideas, to exchange ideas, convey our messages to public and for young students who are going to be a part of future space infrastructure. So that's, I think, enough for beginning.
Thank you. Thank you for mentioning the point of education and formation of the young generation. This is fundamental, because of course it's clear for deep space we need people more than other things. Thank you. And now I invite Mr. Gomi from Japan, JAXA. JAXA will chair the minister meeting. Please, Mr. Gomi, let us know your vision, the Japanese vision.
Okay, thank you. I'd like to present deep space exploration post-2024 scenario in JAXA. JAXA is one of the ISS member. JAXA continue to operate ISS GEM Kibo. Especially, JAXA is making focus utilization of Kibo module. For example, microgravity experiment, microsatellite deployment, and exposed materials. We estimate the space radiation effect. So post-2024 scenario, JAXA has a scenario of lunar exploration. We are researching the key technologies. For example, small lunar landing demonstration mission, SLIM. SLIM stands for the smart landing for investigating moon. And then we are researching also key technologies, life support system, or land view docking system, or habitation system, etc. And then we are planned to the water ice prospecting mission, and maybe participate in US-led Deep Space Gateway program. This is not yet the decision. And human lunar surface exploration, sending a Japanese astronaut, etc. In the future. And we are also planned to Mars satellite sample return mission. It is called MMX in early 2020s. JAXA has a heritage, Hayabusa and Hayabusa 2. President of DLR introduced already. Thank you for the presentation. This is an asteroid mission. So we are researching and make a project in the Mars satellite sample return mission. And how to manage the next lunar and Mars cooperation. And we basically the international corporations. JAXA needs international corporations. And also we have to consider the ISS heritage and lessons learned. This figure shows JAXA's vision and concept. This is not the Japanese government one. We are considering a cislunar station and various activities on the lunar surface. JAXA is interested in the habitation module, human lunar lander, and the logistics module. And also interested in the water ice prospecting mission and various activities on the moon. This is proceeding international corporations. Okay. How to manage next space explorations? We have a good opportunity to discuss in Tokyo. This is my important role currently. ISF2 meeting will be held in March 2018, next year. So ISF2, limited governmental people can attend the meeting. So we provide the two kinds of side event. One is young professionals, one is for industries. Please, web application will be welcome from next month, October. Thank you for attention.
Thank you, Mr. Gomi, for giving also this perspective and announces this interesting forum, which there will be many opportunities to discuss exploration issue. And now I invite Mr. Werner. Mr. Werner, the Director General of the European Space Agency, as you know, have a bigger responsibility because he has 22 member states and 14 participants to the exploration program in this moment. So please, let us know your vision.
Thank you very much, and good afternoon. I will talk about this idea, what is going after 2024. And I think what is very important that we, before we start with all the different types of missions and ideas, that we look into what do we need really after the ISS, whether the ISS is still there or not, let's say after 2024. For me, it's clear we need in exploration human and robotic activities. We need a microgravity lab because we have to do still research, fundamental research as well as application. So that means fundamental research. We need also international activities because we know that space is bridging earthly crisis. We should not underestimate this geopolitical effect of exploration. It should be inspiring because inspiration is even beyond just the space guys. Also other people are inspired by space, and this is good for our society worldwide. And it should be useful. This is, of course, a request. Science and development, and it should be a springboard for future activities, deep space travels, which are, with today's means, still a little bit complicated. For me, it's also important that we have independent access for different actors, private and public, and we do not limit the access to one or the other nation, so it should be very open. And it must be more than just a single mission, because if we want to go for a sustainable solution of exploration, then we need more than that. And it should be multi-purpose. And when I listed all of this and tried to find a solution for it, I did not come up to just a single solution. I came up to two solutions. And these are, number one, frequent Earth orbit activities, because the researchers who are working in microgravity would like to get their results quickly back. They want to investigate what happens in microgravity, and at the same time, an international exploration activity. So, and again, it must be more than just one mission from my point of view. We heard already from Bill. Bill, I copied your picture, I hope with your acceptance. So this is something which is a long-term vision also to go beyond low Earth orbit, to go beyond the moon. And the question is what can be done in this path? And from the European perspective, we have in ESA, through our member states, a clear commitment to what we call the European Exploration Envelope Program. It is a unified vision for Europe's space exploration, and it's aligned also to Space 4.0, which I explained here in this conference several times. And if you look into this exploration envelope program, it has three main destinations. This is low Earth orbit, it is Moon and Mars. So if we now consider what can we do where with today's technology, so it's very clear also what Bill was saying. If we want to go to Mars, there are really challenges. Even if we have a little bit faster transportation, 2 years is still something we need for that. And there are health issues, there are propulsion issues. If we land on the surface of Mars, the gravity is much stronger than on the moon. So there is a psychological aspect. Just go out tonight and look whether you see Mars, and then you could say, okay, now the other way around, I'm standing on the surface of Mars and look back and see just a tiny blue dot, and this is then your home. So radiation is an issue, communication is an issue. Houston, we have a problem, or Houston, we had a problem that was really rapidly transmitted. If you are close to Mars, it takes 20 minutes. So therefore, and if you get the answers, another 20 minutes. So this is a little bit complicated then to get direct help. So it is really a big challenge. I'm sure humans will go to Mars and beyond. I'm really sure if we maintain our Earth as a very nice planet, then we will do also that. But in between, let's go to the moon. The moon is very close. You can do it even during summer vacation. But on this way, we from the European side, we tried to support also the Orion and Deep Space Gateway by, for instance, the European Service Module, which is part of the new transportation means produced in the United States. And at the same time, we are working together with our Russian colleagues on the Lunar Resource Lander. This is a part also where we are aligned very much to develop technology and science on the moon. So of course all of this should have also some, as I said, some long-lasting activity. And as I explained at a different place over here, for me the solution is to have an open concept, not only what we are doing usually, a mission, a project, a program, but an open concept. Just because of the restrictions of time, I will not go through all of this, but I'm quite sure there are still some questions open. I can explain that whenever you like to see it. And for me, the outcome of this consideration to have a short-term, mid-term, also exploration aspect where we can do really human and robotic exploration at the same time. This is for me the location Moon. Of course, again, it is at the same time also a stepping stone, a springboard for future activities. You heard this already from other speakers. For instance, resource management. In the future, we should not move and bring all the stuff from here to another celestial body. If we have some material over there, we should use it, 3D printing or whatever you think. So it should be human and robotic, it should be international. For me, it's very important to open it also to public and private entities, not only the public one, not only the traditional way of exploration, but also it is outreach. And when you see STEM, science, technology, engineering, and math, the A stands for any other subject, because I'm quite sure that also even lawyers are inspired by space exploration subjects, as we know here in Adelaide in the discussion. So what are we doing there? Moon science is important. The moon is an interesting body. Cosmology, especially also to do from the far side of the moon, a radio telescope to look deep into the universe. We can do fundamental research, technology development, as I mentioned earlier, transportation developments, testing of new communication means, logistics, resource management, and also planetary defense to look into the universe if something is hitting towards the Earth and endangering our life. All of this is called the Moon Village, which does not mean some single houses, a church and a city hall, but it's just a community either of robots or humans, or both robots and humans, and it should be, and this is a very important message from my side, as an international activity, it should have a free and open access. Thank you very much.
Thanks, Jan, for your presentation and for express the idea of an open concept of the future roadmap. Mr. Laporte, please present us the Canadian vision.
So I guess Mrs. DiPipo didn't like my speech and she's left already. All right, so good afternoon, everyone. With respect to the Canada's look at Journey Beyond LEO, clearly we are a small country when it comes to being a participant in a partnership where we've got Europe and the US and Russia and Japan. So we know our place in terms of this partnership, and we're very happy to be a part of it. However, when it comes to vision, we are a contributor to those visions. So we are looking forward to the discussions and the collaboration that are being offered to us from our NASA colleagues, but together as an international community, as we look to outer space, we certainly feel very, very comfortable that we can ensure that Canada's participation will be beneficial to Canada. The Canadian space sector, or any space sector, is one where we use space to inspire. And I want to certainly acknowledge the fact that as important as it is to ensure that we have the right technology and the right science, and when we do human exploration, we can bring our astronauts back alive, the public policy aspect, the inspirational aspect is just as important. And our government, our politicians in Canada keep reminding us of that fact. So clearly that needs to be a very important consideration as we go forward. And if you're going to have an exploration program, certainly if you're going to have a human exploration program, you need some astronauts. In Canada, we just went through a full year of assessments and evaluations to select 2 new astronauts, and You see Josh and Jenny on the picture here. They were presented to Canada during the largest Canada Day event by our Prime Minister, as you can see on the picture there. And that speaks to the interest of a nation's population in space. And I'll share with you that as we look at scenarios going forward for beyond LEO to outer space, we're looking at taking a very national, very open, very public program perspective with respect to that. And the reason why we're looking at doing that and involving the nation as we go forward to outer space, when we did the astronaut recruitment program, we did all of it on social media. And we've attracted a tremendous amount of attention, particularly when we had about 70 candidates left or remaining in the competition, and we put their profiles on the web. Then the media exposure was just fantastic. We got a tremendous amount of positive feedback from teachers who were able to inspire youth to stay in school when they showed the profiles of these exceptional Canadians to their classrooms. We got a ton of very, very positive exposure. And all of a sudden, a nation is now coming to grips with the fact that we've got extremely talented applicants, extremely talented Canadians who are wanting to be part of this outer space venture. And to give you an idea of metrics, Canada has, a bit more than 37 million inhabitants. We got 22 million impressions on all of our social media. So that is a tremendous proportion of the population that came and then had to look into our space program. So as we go forward, we clearly need to make sure that when we discuss options with our partners for going to outer space, that we always bring the entire nation with us together as we embark humanity on the next outer space journey. Now, from a more technical perspective, as we move beyond 2024 and go into outer space, we're currently in discussions now with industry and with academia in terms of what Canada could contribute to the partnership. So we've issued a number of contracts to look at different options, and as we finalize some of the discussions at the international partnership level, then that would put us in a good position to go back to our government and speak to specific costed options so that we can make a final decision on how Canada will be contributing. And of course, we're looking into some classical things. Of course, we're well known for the Canadarm, so should there be a Canadarm3 on the next station, certainly we would like Canada to be in a good position to contribute to that. But we've looked into other examples like relative navigation and mobility. Medicine is also a very big interest to us. And because we're looking at rallying the country behind these outer space programs, we've also issued a request for information very broadly out to Canadians and said, well, you know what? Out of all those things that we believe we have a technical strength in, what do you, Canadians out there, believe that we should build as a new strength? What do you out there think that we should contribute to the outer space program that we are currently not doing? So we're having a lot of fun with that. We got a tremendous amount of very, very innovative ideas in terms of what we can do by very creative people, and it's been and it continues to be a very worthwhile exercise to engage. So in closing, just want to say that as we look at different scenarios for going cislunar, going to the moon, going to Mars, there are probably three things that I think are key principles in terms of making sure we succeed going forward. The first one would be to certainly ensure that we look at a very modern approach to our partnership going forward. If anything, the ISS has taught us very early on that none of us can do this without an international partnership. We've learned some really, really great lessons there. We now need to, equipped with that, we now need to look at how we're going to collaborate in a more modern, innovative partnership going forward. And also then we need to develop the skills, the competence, and the knowledge in the youth that are actually going to be creating those ideas and thinking exponentially as we move forward to outer space. And finally, we need to set conditions to make sure that science and technological development can be successful going forward. Thank you very much.
Thank you, Mr. Laporte. So for Canadian people, astronauts are wanted in this moment. And I invite Mr. Yulong to present the China vision of this evolution.
Thank you. Now I'm very pleased to attend this forum held by AIS to discuss the global space collaboration roadmap next 10 years about. I'd like to give a brief introduction. The CNC put forward the medium and the long-term roadmap, some of the rough idea, mainly covers the three activities. Here's the slide show you the lunar application program. Since 2004, start the lunar program, we have organized 3 STEM mission, the circling, landing, and sample returning. Now, so far, we have successfully conducted 4 missions, including Chang'e 1, the circling exploration, Chang'e 2, the precursor and landing, 3 landing and revolving exploration, and Chang'e 5 test 1, and the re-entry test for sample returned mission. The result received worldwide attention, made good cooperation carried with the ESA. Later on, China will continue with the NANS and SANS polar missions, a lunar scientific research station, built the platform to support scientific observation, scientific experiment, and technology validation. They will provide important support for the deep space exploration like Mars mission. In our future mission, lunar mission, China will take to the open outside. They continue to strengthen the international cooperation with the agents. In various forms, the cooperation including the scientific research, collaboration mission, and engineering development. Here's the lunar exploration planned after 2020 is a lunar polar region experiment, a lunar research station. The second is the Mars mission. China's first robotic Mars mission will officially start from the last year with the plan to launch the first Mars probe in 2020 to conduct the joint exploration of circling and revolving the survey. Sample returned the mission for Mars will be carried out about a later stage. The feasibility study of the exploration plans for the authority exploration, Jupiter, and other missions will be initiated as per the timing. CNC is willing to carry out a coordinated joint Mars mission with the space engines, share the deep space infrastructure, and devoted to the space collaboration and innovation with the achievement to be shared by all. Here's the Mars program, the Mars mission, and jointly orbiting, landing, revolving the survey on the surface of Mars. The third is human space flight. As you know, the China human space flight program and have the 3 STEM procedure. First is the manship. Second, the space lab construction. All 2 STEM have finished and successfully. After the STEM, we are with the space station is the next step. It's the plan to complete about 2022. After this steps, we are willing to work with the space engines and the international community for international cooperation, carry out space science research, experiment, and so as to provide support for the future manned lunar exploration and manned Mars mission. Today, the both developed country and developing country pay my high attention to the activity patient in the outer space activities. Peaceful exploration and utilization for the outspace is the persistent pursuit for humankind. The development of the space technology, exploration of the vast universe, and encourage the young generation from the innovation will make the great and the profound impact on people's way of the production and the living. UN proposed the UN Space Plus 50 for setting up a new mechanism for the space exploration and innovation. Space engines are jointly pushing forward to have an international space exploration roadmap, ISECG, and emerging space country and developing country all set up their effort in space exploration. Therefore, we are standing on the new historic starting point, facing the world toward the next 10 years to conduct mid- and long-term international space exploration. It is required to have the mutually beneficial global partnership between the space powers and the developing country, to have exchange cooperation among government, enterprise, and social force, and to have the exploration achievement shared by all, so as to service and increase the welfare for mankind on a high level. Thank you for your attention.
Thank you, Ms. Yulong. While Canada highlight the space economy effect, you highlight at the end very important things. Exploration is also culture. It's a way of living, and this is a very interesting vision for the way forward. And now I invite Monsieur Jeannie Legal, La France.
So, thank you. I would like just to say a few words in 5 minutes to set the scene. The first point is that since the first Sputnik, we are going to celebrate the 60th anniversary next week, space science has gone from strength to strength. But this extraordinary field for innovation has also become a kind of breeding ground for entrepreneurs. And so the first idea is that we now need to establish a balance between science and the dreams of industry newcomers. Now, what are the scientific issues for a post-2024 scenario? In fact, in France, we consider that we have to be focused on 3 points. The first one, to studying the planets and small bodies of the solar system. Second point, exobiology, to look for signs of possible extraterrestrial life. And the third point, astronaut missions to prepare long-term human exploration programs. These are the issues in which we are interested for the post-2024. Now, a few words about human versus robotic exploration. It is clear that even if international crewed exploration seeks to establish a permanent human presence beyond LEO, it has to be proposed for missions where a human presence is mandatory. But in parallel, we see also the current exponential growth of robotic applications and artificial intelligence, plus virtual reality, and in total, this shows that in many cases, we may be able to rely on robots, possibly humanoids, to perform exploration. A few words about robotic exploration of Mars and the solar system. For CNES, robotic exploration of Mars is a priority. We have, of course, French instruments on board of ExoMars, which is a very, very shining mission of the European Space Agency. An orbiter is in orbit around Mars, and ESA will launch a rover in 2020. And on board of this rover, we will have French scientific instruments, but we have also cooperation with NASA. We are on Mars, we on Curiosity, and we will be on InSight next year and Mars 2020 later on. But our priority for post-2024 robotic missions is Mars and deep space solar system bodies. And I would like, in particular, to highlight the possibilities which are offered by current developments of nanosatellites and microsatellites for new solo or accompanying missions, and of course, with very low cost, which is at stake. A point about cooperation. We think that cooperation is key to exploration, because given the required budgets, international cooperation, I think that it is both a duty and a necessity, and of course, we have to keep in mind some local, national, or regional strategic interest, but we need to identify the key contributions involving industry, and I think that we should also seek to involve new emerging space countries as much as possible. We have today a big project of exploration, which is the station, in cooperation, but it is clear that we can widen this cooperation, and I think that it is what we have to do. A few words about the role of private enterprise, because given the global challenges of post-2024 missions, private partners will have to be sought, and I think that this will happen if we succeed to encourage private companies to invest in space and facilitate increased spin-in and spin-off between terrestrial and space know-how and technology. In conclusion, I would like to insist on the fact that the role of space agencies in strengthening synergies is very, very important, and we have to strengthen the synergies between science and innovation. We had recent and spectacular cost reductions in satellite and space launches, and it makes possible what was previously just a concept, to send a spacecraft to Mars with 4 to 6 persons in space for 2 years. 5 years ago, it was impossible. Now, there are a number of panels in this Congress which deal with this possibility, because it is becoming a reality, let us say, for the decade 2030 and beyond. This very fast-changing environment, we think it as an opportunity for new post-2024 exploration missions, and that also means that our role as space agencies is crucial to foster synergies between the public and private sectors, and perhaps the most important, between science and innovation. Thank you.
Thank you. Thank you, Mr. Legal. Exploration is also, of course, science. It's the top priority goal. And now, Mr. Battistone, Italy, and his vision for, this is not the first slide, this is the...
On the beginning?
Yes,
okay.
yes.
So thank you so much. I think it's a really great occasion for thinking and let you know about how the various agencies are looking forward to the deep exploration. We heard that the space exploration, as space in general, but space exploration in particular, is a tool with multiple meaning. Science and discovery was just recalled. Education inspiration has been introduced by various speakers. Exploitation of existing capabilities. New enabling technologies, I mean, this is a really important part. I mean, getting goals which are very high and difficult stimulate in a manner which is unique the development of new technologies, and deep space exploration is a lot about that. Human achievement is about the cultural background, about the reason why we are here looking for new borders to be achieved and passed. And international collaboration is a demonstration of tonight. Space economy has been mentioned many times during this discussion. And benefits for non-space users. I think few people will go to deep exploration, very few people will go to Mars, but many, many millions or maybe billions of people will and are benefiting from the result of these researches. So this new exploration paradigm is about globality of the approach. You see here an ensemble of countries which do not reflect exactly which has been the great achievement for ISS. There are new, extremely important players. China is with us today, but also India and other players are becoming more and more effective in exploration activities with very ambitious programs, with different approaches, sometimes more expensive, sometimes less expensive, but equally ambitious and equally forward-looking. So I think we have really now to make an effort to cluster and to get the critical mass in place to do something which is really making a step forward based on what we know today from the previous, recent, or even past achievement. And I think has been said several times, but we should focus on that. The colonization of cislunar orbit is something we should do as soon as possible. It's an intermediate step which is bringing us significant advantages from the point of view of technological development, opportunities for real international global cooperation and collaboration, a new generation of hardware and software and tools, a good, important step for the giant step, which means going to further planets like Mars. And we can do that because basically the technologies for this cislunar orbit colonization are available or close to be available because the challenges of the duration of the flight are less challenging and difficult than the 1,000 days in space. So to do that, we should figure out a sustainable short-term plan which exploit current assets and expertise. We have plenty of those. Some have been mentioned. We have plenty of those. So a cislunar infrastructure as an enabling step for deep space lunar exploration is what we need to have, and we should work hard to make this happen. How Italy can contribute? We have a very significant background experience coming from both the robotic exploration, ExoMars 2016, 2020 has been mentioned, but the one which is even more suitable for deep space exploration in preparation for human exploration is what has been done for the activities on the ISS, the habitable modules, the cargos, the nodes, and the cupolas, all of these elements which were also mentioned during the introductory movie. Obviously, we have to progress from that. We have to see a new interconnection capability to secure interoperability between what are the existing interfaces for the ISS and interfaces for new participants, like, for instance, the China docking elements, or introducing augmentation modules and cargo carriers which are based on the Cygnus evolution, which is derived for the cargos and the MAPLM, which were used for the ISS, as well as innovative development, for instance, the one based on inflatable elements for hosting specialized payload facilities. So we have a strong heritage, as other space countries do have, and this is available for developing a concept, and a few have been mentioned around this table and around discussions which have been done also in the last days, so that together we can really reach this goal. A last word about the private sector participation. I think space in the last 10 to 15 years, mainly thanks to the incredible work which NASA did in transforming the low Earth servicing capability for the International Space Station, has made a very bold step toward the involvement of the private sector. This is particularly evident in the United States. We have several examples which were 15 years ago impossible to think about, and today are realities. Really, we should achieve that. The next step, NASA is effectively developing, and I hope we will work to make that a success, is to make commercialization of significant part of the International Space Station is equally bold, but if we succeeded once, you can succeed a second time. And it means that for the future also we should get these companions together with us, agencies, into preparing for the next step. They are bringing in new ideas, younger vision, new technologies, and a cultural background which is sometimes coming not from space, but is tremendously effective when applied to space. I think with this companion and with the experience that agencies at the global scale do have, the possibility to access a cislunar orbit and colonize it are very concrete, and they can happen sooner than expected. Thank you so much.
Thank you, Roberto, and thank you all, because I think that our guests here have really a complete vision from west to east of what is possible, and as you can see, also having a different background, different interests, and different priority, we are not so far from a convergence. I want to open also the floor to your question, if any, and while you prepare or ask for a question, I start myself. I want to start the question to Mr. Yulong. Between many programs, you mentioned the future mission to Mars. So have you listened here both NASA and also the member states of ESA have a challenging mission to Mars, with also a strong contribution from Roscosmos. Do you think that because going to Mars, Mars is not, of course, trivial, and I'm sure that you are not neglecting this aspect. Do you think that in future is possible a cooperation on this mission?
Yes, of course, I think so. Today we talk with NASA, CNF, and we talked with user the RSECG. We have a good cooperation. We coordinated some mission, some the roadmap, the detailed information. So next step, I think maybe need more talk about how to integration, how to coordination. The detailed step, I think so. Next step. So I think if for China, we like to open to our area agents. Share some platform, some mission, scientific research, jointly work together and set up some scientific team and so on. I think I like to do that. Thank you.
Thank you. And I don't know if there are questions from the floor, but I want to ask Mr. Werner. So, Mr. Werner, here there are just 3 member states, but they converge in many points in the way forward to the after 2024. I see that you mentioned the possibility to go on Mars. Have you think to the possibility to have just, because you of course have to consider also the available resource for all this mission. I would like to ask you if do you have considered to have just one mission to Mars, which fly by the moon, leaving a daughter robotic payload, and then go on to Mars in order to accommodate all the interests?
I think my understanding of what we are doing together is a different one. So I'm not looking to just an ESA project to do this or that. We are always open for interaction. Just ExoMars was mentioned. ExoMars is a mission which is launched by Russia. It has payloads from all the different member states. It has even NASA is on board of ExoMars. It is an ESA mission also as well. And this shows that the question of resources, if we are doing it smart enough, and I'm looking again also to China, then it's for all of us a benefit. So we should not duplicate to go to the same place to investigate exactly the same just because of whatever reason. We should try to cooperate wherever it's possible. And then it's when we are saying exploration is for mankind, then we should not say exploration is for national pride. That's a different sentence. So therefore, I think we should do it together. And as I understood also from Bill and as well as from Sergei, but also from our Chinese colleague, that there is really something possible. Also, of course, so we can work together, and we just have to do it. And therefore, I think the question you raised is a nice question, but I would not answer it in that direction. So I think because so the moon should not be understood as a stepping stone, meaning I go there and I go farther, really in a realistic situation. It's more the thinking. To go to the moon prepares us to go to Mars. That's the understanding. So otherwise you have to have a launch capacity, etc., just for that additional launch. Therefore, the idea of NASA to have this cislunar station as a possibility to go either with humans or with robotics on the surface, or do also remote controlled activities on the surface. This is a good solution, and then also to look what can we do from there to a further point. So I think we should, as we have more or less the same opinion over here about the destinations of exploration, and also the ideas were not in contradiction, we should see what we can do. I mean, some years ago, I tried to convince our Chinese colleagues to have not an independent Chinese space station, but after I saw the movie Gravity, I now understood that it's very important. So Sandra Bullock could not survive without you.
Thank you. Thank you. I would have many questions, but I know that the time is not so much. So I invite, if there is someone from the public who wants to intervene.
My question is, technological capability is one thing, political will is another. How likely do you think it is that we will actually see crewed missions to the moon and to Mars motivated by the political will to go, as, you know, in distinction to simply being able to say we could if we wanted to?
So look back to 1975. 1975, maybe you are too young, but I was still a student. 1975, that was Cold War, really a strong Cold War. And at that time, Soviet Union at that time, and America, United States of America, had this famous Apollo-Soyuz docking and rendezvous. I think this showed at that time that we are really above earthly borders. And this is what we are doing today. I have to mention it whenever I'm in Baikonur. I feel really my heart is touched when I see that a Russian cosmonaut, an American astronaut, and a European or Canadian astronaut or a Japanese astronaut are sitting in this tiny Soyuz capsule. Excuse me, but it is tiny. I have to apologize for that, Sergei, you know. And then you have the feeling suddenly, yes, we have some crisis on Earth, and we will not forget about that. But we can fly above that. Isn't that a very nice thing? So I think we have to convince politicians we are above earthly borders, and we are doing this day by day, and this is really the beauty of space.
See, we built equipment to bring people together.
Tiny
closer to each other.
Let them to be close and close. And
again, I think the political thing is hard, but I don't think it's insurmountable, and it's up to all of us to convince our countries and the political systems of which we work and live, how important it is to work together. And the benefits we talk about, the inspiration, the aspiration, the goals, those things are really what drives us as a human species. This is bigger than any one of us. This is bigger than any country. These challenges cannot be done individually. I think you've heard that from all the participants here. But I think the political group will follow us if we can talk openly about them and talk to them in our own words what we see as the benefits individually. So it's up to each one of us in this audience and the folks in this conference not to just talk amongst ourselves in conferences, but to go from this conference with new ideas that we receive from our friends and talk to our non-space friends in our individual countries about the benefits of space and the benefits of exploration, and get them inspired and get them excited about what we can do as a nation, and then we can break down some of those political barriers and we will achieve what we talked about on these charts.
And if I may, we should be ready when the time comes, because we don't know if it is 1 year, 5 years, 10 years, but when the time has come for this political consensus, we have to be very much ready.
And also you talk about probability, and I think the more challenging task we will have, more probability will be to work together through these political issues.
Yes, please.
Hi, so I want to build on that, the previous question and the comment from Italy over there. What if there suddenly was a very strong will to actually go? You had all the will you can imagine, and there was instead a question of how soon can we have humans on Mars? Would you be up to the challenge? How soon can you actually have humans there?
I can answer to that, but I would like to ask Bill about that.
Or
we're ready. I mean, we're doing all the basic pieces now. We're working as fast as we can within the constraints we've got. If some of those constraints got removed and we got clear direction, again, I think we have the ability, we've gained the understanding of how to communicate with each other, how to work together. You know, I don't think I can trivialize how important Space Station has been. It has shown how we can really work together. You know, we've had, and this entire IAF activity, getting a chance to meet with our partners. We meet with each one of them one-on-one in bilateral meetings. We share a common vision. So I don't think there's a technology holdback. It's just that when we're ready to go move. And I think the other thing is, don't discount what we're doing today. We are starting the dialogue. We are starting the discussions. You know, as we start to see what China wants to do and how they want to move things forward, we can figure out ways to work together, and we can figure out ways to team and do things and take the best from all of us. Again, the cool thing about this is, you know, I call human spaceflight the ultimate team sport. It requires 100% teamwork from all the participants for us to be successful. And I think you see, as heads of agencies and members of the various space agencies, all of us willing to come together in an unselfish way to figure out a way that we can advance this goal of moving human presence into the solar system.
Please, do you want to comment?
Yes, I do. So in fact, I'm in agreement with Bill, and I'd like to just, when I read the slide that says, you know, deep space exploration post-2024 scenarios, if you're reading that it implies that we're going to wait till 2024 to figure it out. That clearly is not the title for this session. We've been doing research for 20 years on the ISS to prepare for moments like this. Very, very successful research. And all of us who have all agreed to extend our presence on the ISS until 2024, which is just the next decision, but we've extended until 2024. We're all dialing up the science and the research and the testing and the proving to take us to the next step. So what we're now doing on the ISS is all in expectation of doing the next step into outer space. So fully agree with Bill with respect to the fact that we're ready. We've got a ton of lessons to learn. We've got a ton of new science, a ton of new technology to develop. I don't want to minimize the challenge of going there, but we're prepared, absolutely prepared to go.
Thank you, Mr. Laporte. Roberto, a quick comment, because I leave the floor for another question, and then we have to close. Unfortunately, this is very interesting.
Very quickly on that, I mean, I really like to hear this statement, because I deeply share that we are ready, although we need a tremendous research and development effort to make the technologies which are able to let us do it at 400 kilometers above the Earth or in the vicinity of the Moon for months, but with the possibility to come back quickly to something which is about 1,000 days and which will take 1 year to come back. There is an amount of reliability, self-repairing conditions which are much more stringent than what we have now on the ISS, which should be acquired. But this is why we should do that, because it's the next revolution at the industrial level. Talk about Industry 4.0. This is Industry 5.0 or 6.0. We need that, and we are in the direction to do that. And this is why we do space, because we want progress to be achieved. And more challenging is the next reach, the more the development will take place. That this is the Apollo challenge of these 2000, of the 21st century. This is definitely why we want to do that, the technical people. And if we convey this statement to the political level, I'm pretty sure they will understand that.
Thank you. Thank you. So I know that our distinguished guest has other meetings.